between the variable. If the data are given in terms of ordinal sense, then how to calculate the relationship? To finding it out, or before we enter into the rank correlations, we have to remember at which situations the rank correlation to be calculated. There are three types are there. One, when the ranks are given. When the ranks are given. That means when the ranks are given, let for example in a class that the 50 odd students are there, one test to be takes place. Of all the papers and at the end of that particular semester or trimester, the positioning of the students to be taken into account, and top 10 students are there. The 10 student, how they extracted the top 10 student, means first, second, third, fourth, 5 and so on. Similarly, in another batch, they also will appear the exam having some ranks are there 1 to 10. Now, what is the relationship between the section A's or the first group students rank and what is the rank of the second group students? Is there any relationship or they are completely different? That to be studied. That means the ranks is already given. If the ranks are given, then how to calculate? That is the first step. Second, we can calculate the rank correlations. That means we have to convert if the ranks are not given. And the second way is that when the ranks are not given. When the ranks are not given. Initially the ranks are given, here it is not given. That means in this case ranks are not given. It is to be in case of your nominal or it is the any ratio scale type of data to be that. Let it be the height or it may be the income, it may be let us say sales, right? Those figures are given. Let the sales figure, the 10 different companies are given in terms of ranks are there. First, second, third, fourth, you have to ranking them. But prior to that, considering the sales figure. Students are ranked on the basis of the marks. So, marks is a what type of scale? It may be a ratio or to be interval scale. But that ratio and interval scale after that it will convert into the rank. So, when the ranks are given, the first problem. When the ranks are not given, we have to convert them to the rank, then we have to calculating it. And the third phase, that is called as the when there may be some equal rank. Let for example, you can find while you appear the exam and find that the 2 to 3 students are in the third rank. That means what? Why the 2 to 3 students are in the third rank? Similarly, if you take into account the cricket rating, that the 2 to 3 teams are there, ICC rank. There the 2 to 3 teams are there in a second position or the third positions, or the batsman rating or the bowlers rating or all-rounder rating are there. How the 2 to 3 player to be in a particular rank? If it is so, that means that reflected, that means the same outcome to be that, no, it may be the ratio of the nominal data or it may be the ordinal data what is given that all the 3 persons have to remain the same. If they are the same, then definitely you have to provide the same rank. If it is given in the same rank or the equal rank, then how to calculate the correlation, right? So, these are the 3 different cases are there when the ranks are given, when the ranks are not given, and third one when there is an equal rank. There is equal rank. If there is an equal rank, how to solve it? If there is a single, how to solve it? If the ranks are not given, how to solve it? Now, we start with the formulas. Which formula you have to apply for calculating the rank correlation? Rank correlation can be calculated, it will be depicted by correlation, that is R. You have to make the distinguish between the Spearman correlation, rank correlation, which was to be developed by the Spearman, he take into account in the capital R. That equals to 1 minus 6 sum d square divided by nq minus n. 1 minus 6 sum d square divided by nq minus n. Then what about the n? N is a pair of observations. N is a number of pair of observations. How many pairs of the observations we have to consider for the purpose of calculating the relationship between the 2 variables? That is called as the pair of observations. Now, what is D? D is the deviation among the rank, that is the difference between the rank. Difference between the rank. We have to ranking the variable. Let us say that the 2 to 3 variables are there, we have to rank them. After ranking, we have to make the difference. That difference is called the D, or it can be written as rank of the first variable and the rank of the second variable, or vice versa. We can take the difference also, because we have to take the squaring of it. So no difference whether it is x minus y or the y minus x. The result will remain the same. That is called the D square, right? So the rank Rx means ranking of the x, and Ry means the rank value of your y. Okay. So considering this particular D, we have to put and n. Thereafter we have to calculate the R. Like the Karl Pearson's correlation coefficient, the value is to be lies between plus minus 1. Here also the rank correlation coefficient of the Spearman also lies between plus minus 1. How it is so? Let us start with one numerical example when the ranks are given. Let us say we start with one example when the ranks are given. Suppose there are two variables, x and y, right? X we can take into account, it may be the sales of X company, and the y is the sales figure of your Y company, and their different month. Let's for example their existence of your, we take into account the 6 month sales, and those 6 month sales they can rank. Let for example they starting with the term the 6 months scale has to be write down the 6 months. Let for example the January, February, March, April, May and June. We take this 6 month data, and the sales figure of the X company, they rank their sales in this way. Let us say here is 1, here is 2, 3, 4, 5 and 6. Here if there is the highest amount of the sales to be that, if the more sales then given as the 1, if it is the less sale given the highest number to it, right? That means the highest number reflected the less amount of sales. Exactly the same manner from the Y company, let us say here we take into account the 5, 4, 2, 1 and let us say 3 and 6. Let us say 1 to 6 we have to assign, the values are there for both the companies, the sales are given in both the companies and we have to rank them like 1 to 6. 6 months sales figures are there. Then how to calculate the correlations? Is there any correlation between the sales of the company X and that of Y? But remember here already ranks are given, 6 months sales figure, the ranks are there. In order to finding it out, we have to apply the rank correlation, and rank correlation formula here are 1 minus 6 sum D square divided by NQ minus N. What my requirement? N. N is to be how much? Here N 6, the 6 pairs are there, 6 months figure are given to you, therefore N is 6. Now next is to be D square. For there we have to calculating the value of the D, but prior calculating the value of D you have to remember this is nothing but the rank of X, this is nothing but the rank of Y, because the ranks are already given. If the ranks are given, then we have to applying this particular formula. Right now we have to applying the D. D means rank of X minus rank of Y. You have to take the difference between the both the ranks. Now what is the outcome? It is minus 4. This is 0, this is 0, this is 2, this is 0, this is 2. We find the difference between the ranks. After that, we take the D square, right? You have to calculate the squaring this of this particular column. While you are squaring it, it becomes 16, it becomes 0, again 0, this is 4 and this is 6, this is your the squaring of this one, right? It is 0 and it is 4, right? Then while you add this, what do you obtain? It to be 24, right? This is nothing but sum d square. So I am pile some d square and the pair of observation is 6. Now you have to replace it and the values to be here. Now rank that equals to 1 minus 6 sum d square, it is 24 divided by n is 6, that means 6 cube minus 6. Now how to simplify it? 1 minus, let us say 6 into 24, let it be there. Now if you take common 6, it is 6 square minus 1. I mean 1 minus 6 cancel it out, it is 24 divided by 36 minus 1, 35. Now take LCM as 35, so it becomes 35 minus 24 divided by 35, right. So that equals to, the outcome is to be, here is to be 11 minus, it to be 11 divided by 35. Then the net result what you obtain is 0. We have to take the the division of it, 11 divided by 35, and the outcome is 0.31 and 4. So what is the correlation between the sales figure of both the companies in 6 different months? Here the outcome is to be positive. Remember, first sign we have to take into account, because the sign reflected the direction of the relationship. Here it tells us the positive sign. That means both the sales company, both the sales figure of both the company, the sales figure of both the companies of the last 6 months move in a same direction. Then what is the, the extent of the relationship? The extent of the relationship is very negligible, because it will be positive, but it is to be less degree positive. That means it is less than 0.5. It will lie between the 0 and 0.5. Because in our previous classes we already discussed the value of the correlations lies between plus minus 1, but if it is nearer to the 0.5 to plus 1, that is the high degree positive, in the same manner minus 0.5 to the minus 1 is the high degree negative, and 0 means no correlation between the variable. 0 to 0.5 is the high degree, the less degree positive correlationship between the variable, and here is to be less degree negative correlationship. As in our calculation, here we find the value of the correlation between the two sales figure of both the companies in the last 6 months is to be 0.314. That reflects the existence of a less degree positive relationship between the two variables. Okay, this is the way to calculate when the ranks are already given. If we calculate the ranks are given, then this is the process. Right now we have to move to the next example where the ranks are not given. We have to assign the rank to them first, thereafter we have to simplify the problem. Now we start with the second example where the ranks are not given. We have to assign the rank first. So prior to that, let us start with the example. The examples to be here, let us say we take the two variables, that x and y. Here it represents the height of the two persons. The heights are given, it may be in terms of your, let us say, the small height to the large height. Let we take into account 6 persons height with their weight, height and weight. This is the height and their weight. Is there in the relationship between the height and weight? But the height and weight both are given in terms of your data. It is the interval data are given. In the interval data, I randomly take the heights, assuming it is not exact figures are there. Let us say random figures are there. The height to be 105 in terms of inches, right? It is 165, 135, 140 and 120. Let us say it is to be 145, right? This is the 6 persons height are given, and corresponding the height we take the weight. The weight have to be, let us say 100, let us say it is 175 kilogram, let us say 80 kilograms, 70 kilograms, 60 kilograms, let us say it to be 86 kilograms, right? 6 persons height is given, 6 persons weight is given. Now find the correlations in between. We know the data is given in terms of your not a rank basis, therefore we can straightway move to the Karl-Pearson's correlation coefficient. But our target right now is to be how to calculate the rank correlation. In order to calculate the rank correlation, first we have to convert the said data to the rank. How to rank it? So rank can be takes place of your both variable in the same direction. Same direction in the sense we can rank it in the ascending order or we can rank it in the descending order. If you rank x variable in the ascending order, definitely you have to rank the y variable in the ascending order. But if you rank the x variable descending order, exactly the same pattern you have to rank the second variable, that is y, in the descending order. There is no, mix up the component, it to be in same direction, x and y to be ranked in the same order, right. Let us say both we have to rank it in the ascending manner. So while you rank it in the ascending directions, let us say which is the minimum one. In this case the minimum one is to be 105, let we pick it as 1. What is the next highest? The next highest is to be 120, it to be 2, 120, then next highest is to be 135, this is 3, next highest is to be, this is 4, okay, this is 4, 140, and the 5 is to be 145, and the 6th one is to be 165. So you have to rank it 1 to 6 in the ascending order. In same way you have to rank the second variable, that is your weight, and the minimum one is to be 60, we have to put it 1. Second minimum, next highest is to be 70, you have to put it 2, then 80, then 86, 4, thereafter 5, and then 6. This is a way to calculating the rank. When the ranks are not given, you have to rank in the both the variable in the same direction, either ascending or descending order. Here we rank both variable in the ascending order. Then apply calculating the term d. D means the rank of x minus rank of y. While you take the differences, the minus 4, it is 0, this is 0, this is 2, this is 1, and this is also 1, right. Then next step is to be d square. D square to be calculated as to be 16, 0, 0, and this is 4, 1 and 1, and 22. Sum d square turns to be 22. Now after calculating the values of the sum d square and the number of pair of observations, that is your 6, now put inside the formula to be r, that equals to 1 minus 6 sum d square divided by nq minus n. Now 1 is there minus 6 sum d square to be 22, 6 into 22 divided by nq, nq is to be, n is to be 6, therefore it will be 6q minus 6, then it is 1 minus 6 into 22 divided by 6 common, 36, 35 minus 1, 35, thereafter it is to be 6 cancel it out, take LCM as 35, then 35 minus 22, 35 minus 22, and we find it with a 13, right, 13 divided by 35. The outcome is to be, you have to calculate the ratio between 35 and 100, 13 divided by 35, 3.71. 371. So 0.371 is your rank correlation between the height and weight. That reflect, again there is a same relationship, positive relationship between the height and weight. If weight increases, height increases, or height increases means weight also be increases. But how much? If height increases by 1, weight increases by 0.37. That to be the conclusion, right, and both move in the same direction because it is given to you plus sign, plus 0.371. Therefore as they have to be moved in the same direction, we can say there exists a positive correlationship between the two variables. So we complete the two problems. One is given when the ranks are given, and second when the ranks are not given. Now before we proceeding to the when there is a similar type of ranks, I mean when the same repeated ranks are given, then how to solve it? We have to take into account another example to apply the term rank correlation, considering the term what is called as the equal rank or it will be unequal rank. Let us start with one example, finding out the pair of observation when the rank are given to you and the deviation of the ranks are given to you. Here we take one example where the value of the rank correlation is given as 2 upon 3. The sum of the squares of the deviation of the rank, that is the sum d square, is given as 55. If the number of pairs, right now you have to calculating the number of pairs of observation, find the pair of observation, that means your target to calculating the value of n. What are the given things? The given things are R is already given 2 upon 3 and sum d square is given as 55. Then if these two information is given, then how to find the value of n? That is the question. Now let us say we start with the answer. These are the given concept. Now rank correlation can be calculated 1 minus 6 sum d square divided by nq minus n. Now you have to putting all the values. R is to be 2 upon 3, that equals to 1 minus 6 sum d square is to be 55 divided by nq minus n. Now if it is to be, let us say, turn to this side, that means 6 into 55 is to be 30, then 30 plus 3 33, 330 is this numerator divided by nq minus n. Let turn to be this side, the 1 minus 2 upon 3, I mean the LCM is to be, let us say, 330 divided by nq minus n, and this to be 3 less 2, 1 upon 3. Now if you cross multiply, it becomes nq minus n, then it will be that equals to 990. Now it will be nq minus n minus 990, that equals to 0. So this is the equation you got. Then how to simplify that particular equation? I mean what the value of n is given to you, nq minus n minus 990 equals to 0. With the help of the Milton factorization we can do it. With the help of your quadratic equation you can do it, or using any polynomial equation you can do it. Now there is another technique to do it, that is called as the heat and trial method. As you know, it is given to you nq minus n, that equals to 990. Now you have to put the value of the different value of n, starting with the 1, 2, 3 like that. If you put it one by one, then what you find? 1q is not satisfied, 2, 8 minus 2, no it is not 990, like that we have to put. When we put the value, n equal to 10, then we find it is to be 10q is to be like this, 1000 minus 10, yes it is 990. That reflect that n equals to 10. What it reflect was, that means n minus 10, it is a divisible factor to that particular equation. As n minus 10 is a divisible factor to that equation, thereafter we have to dividing it. Let us say we know the equation is to be nq minus n minus 990. Right now we have to divide it with the help of your n minus 10, because n minus 10 is a divisible factor. Here you put to be n square, then nq minus 10n square. When we deducting it, 10n square minus n minus 990. Now put 10, while you put 10 n, then it becomes 10n square minus 10 100 n, right? That much divided by, I mean you have to deducting it, we can finding it out, it is 99n minus 990. Okay, we have to put plus 99, then it becomes 99n minus 990. So it finds this particular equation, I mean nq minus n minus 990, it to be written as n minus 10 whole into n square plus of 10n plus of 99, that equals to 0. So, we can equating this equal to 0, this equal to 0, but when in equating this term equal to 0, we find it is a imaginary number to be that, right. We can finding the value of n never turns to be imaginary, that reflected that n minus 10 equals to 0, I mean n equals to 10, right. So, this is the way to calculate the value of how many pairs of observation if the ranks are given to you, right. So, this is all about of this particular problem, how you have to finding out the pair of observation if the ranks are given and the deviations are given. After this, we have to start with the next problem where there is the equal rank to be takes place. For equal rank, there is a separate formula. We have to write it down and explain with the help of a separate example.